Granted, it is a little outdated because I haven't updated it in a while, but they removed my URL. We used to be lssu.edu/chemistry. Sorry, I can never find my mouse when it's /chemistry, but now it is under lssu.edu/College of Science and Medicine /School of Science and Natural Resources and then /chemistry, because they wanted it housed in, and I need to have like a chat with the person in charge. The problem with our website is we don't have a person to do the website. There is not a dedicated website person. We used to have one and then he quit.
When they ever rehired anyone.
They have rehired people, but like a lot of positions that like state people come in and they find out what they're dealing with and then they leave. So the person that is doing the website, who trashed my website for chemistry, is not a person who is trained to do that. So that's the fun of the website stuff.
IT is a lot of like,
Oh,
no
we'll
offense,
get
but
to
they
it.
don't know what they're doing. Because like,
But
I called and I said, because I got impatient waiting for an email. And I was like, hey, I can't access this. And he goes, okay, so go to my.lssu.edu. I said, I did that. He goes, okay, and then you put in your credentials. I said, I did that. And then he's like, now click on Anchor Access. And I'm like, bro, that's what I can't do.
Yeah, you just have to find which browser works and then you got to try all of them.
Well, mozzarella Firefox.
All right. This is the rhetorical question. Are you guys ready for registration? So classes are up. If you are one of my advisees, you've got an email from me or have already met with me. If you want to meet with me, if you're my advisee on Friday, it has to be virtual because there's no school on Friday for my children. So I need to go take care of that. Okay, so make sure you check your schedules, have your plan figured out, and remember, if you do not go to see your advisor in some form, you won't be able to register because they have to remove your hold for you. All right. Does anyone have questions about registration? Yes.
So I think I've asked this before and I thought I understood it, but campus chemistry doesn't have a requirement to take 495, which is senior research, right?
Correct.
So then 499 is required, and that's where you would present your senior research?
This is correct.
So I kind of was thinking about doing a senior research project anyways,
Yes.
but now that I'm looking at my schedule, I don't really have room to block in those 2 credits to actually do the research.
Yes.
So I guess I'm just a little confused, like what I would be presenting if I didn't go with the research route.
Typically, the students that don't take 495, if you had an internship or something you wanted to present, you could use that. Otherwise, they do the literature project, and then they're relying solely on doing that research like during 499, which I do not advise. If you can get it done before that on your own time over the summer or something, you can do that. So one of my students did that, was working on stuff over the summer to do the 499. Yeah, if you don't have the credits, that does make it challenging. But even if you have a literature project, you still need to have a faculty advisor advising because somebody has to read your paper and give you 2 cents on things. Other questions? Registration otherwise? If you are not taking 495 next semester, you must take it in the fall. Everybody's a junior here, right? Yeah, you must take it in the fall. Or I would not advise taking it in the spring with 499. Okay, so here's your first poll of the day. Do you have a topic? I have to start the class first. All right, so do you have a topic?
oh, if there's anyone that needs protected horticulture and it's not like on the schedule for next semester, go talk to Johnson because there is a group of students that are trying to get it on the schedule.
Do you know how many there are right now?
There's like 4 or 5 right now. Was it 6 this morning?
Yeah.
Was this via Professor Southwell?
Yes.
Okay.
What class is it for?
Protected horticulture. If you are a cannabis chemistry or associate, then you need that class. There was a little bit of sneakiness with that not being, that was omitted from the schedule. I only do the chemistry schedule, so you can't blame me.
Yeah.
Who needs forensics? Are you taking also advanced cell
I don't think so.
next semester or at all?
I don't think I take that at all.
Are you taking spectroscopy then?
Yeah.
Okay. Okay, so if you're taking forensics, that lab is probably moving to Thursday afternoon instead of Thursday morning to not in conflict with advanced cell biology. All right. Okay, so we have a split of people who have topics and people who do not have topics. So the people that don't have topics, you can also answer this, or all of you. Do you have a faculty advisor? So this means this is like the conversation that you have with a friend you've been seeing or hanging out with, and you can't decide if you're friends or not. You have to actually have the conversation where you say, will you be my advisor? So have you had this conversation with your faculty advisor? What I meant was like, you know, the conversation, if you're in the friend zone or not in the friend zone. You have to actually say, we in the friend zone.
Did you submit
Hmm.
the poll?
I did. It's advisor is the poll.
I don't mind that showing up. There it is.
Okay, so while you're answering that question, a couple of dates and things have been shifted around because I had the wrong date for senior seminar. I'll post this on Moodle also. Okay, so we're at the week 9 mark, which we've already changed. So if you have not finished your research ethics training, make sure you do that soon. So today we're doing designing experiments. Notice that I removed some assignments that were probably could have been interesting, but maybe busy work when you guys should be spending time doing your proposal stuff. So previously your draft for your proposal, your rough draft was due next week, but I've given you an extra couple of days. So it's now due on the 18th, which is a Sunday. So you have a weekend to do that. So next week we're talking about giving a presentation. So you're going to be presenting your proposals to faculty on the 28th and also November 4th. You'll have to be ready to go on the 28th, and we'll draw names to see who goes. So make sure that you're ready on the 28th. So the next week we're doing presentation. 10:21, sorry, is working day. So we're not going to have lecture. You can work on your proposal, even though there's a draft. Hopefully I will have your draft back to you at some point before your proposal presentation so you can put that together. So on the 21st, we won't meet, but you can be working on your proposal presentations or your final proposal, which is due the, did I really say the 11th? I think I meant the last day of class,
So that's 16.
16th. Your final proposal would do the last day of classes and the last day of this class, which is 16th. So I'll move that. So that should be that last line there. So that will be another day that we don't meet for class. All right, so for those of you that have a topic, you at least have something to work with. If you don't have a topic, we need to find one soon for you guys. All right, questions on the rest of the semester?
Our final proposal, is it like gonna be due at like 11:59, or is it gonna be at some odd time of the day?
11:59.
Okay.
That's my, I don't know. I feel like at the end of the day, it's when it should be due. Not like 2 in the morning, or Professor Southwood does 10 a.m.
He does like 5 p.m.
Yeah.
or
Like,
that.
And it throws me off.
Business day. I like if you are a late person, you can work on it late and then turn it in. It doesn't help the people like Brianna who would be up at 3 in the morning, but she's not in this class. So 11:59 on 11:16, which is the last day of class, and we're not going to meet on the last day of class because it's silly. Just don't tell the dean.
What is are we gonna have a final one here? Or like,
I don't think we have one scheduled.
we don't, okay.
USEM, for some
Yeah.
reason, has one
Okay.
scheduled. And sometimes a lab occasionally will get one scheduled, but just
Okay.
one section of the lab. So it's registrar dependent, whatever.
Okay, I haven't looked,
I am not going to give you a final. Your final is your proposal.
Okay.
Okay. And so I'll get back proposal drafts as soon as I can get through them. Yeah. So, and those you can find on Moodle where you submit, and then like if you scroll right, there's always the feedback. That's how I'll get back to you. All right, what else? And then you'll have your presentations, and we'll discuss the details of the presentation next week. Right, other questions on that stuff? And if the people Zooming from home, if you have questions, just pop up a query.
Is it only 4 more weeks left of that, or 5 more weeks left?
We have, today we're in week 9.
Yeah, so 5 more weeks.
Yeah, it's not a lot, which is why I couldn't push back the draft
Yeah. No,
anymore.
it feels like we have so much longer, but we don't.
No, it's exciting and not at the same time.
It's stressful. but it is.
Okay, so today we're going to talk about experimental design and how to design your experiment. So if you are having a topic, or if you're not sure, you're trying to narrow it down, maybe talking about experimental design will help you get to that point or work on your proposal. Okay, so we know what an experiment is roughly. An experiment is a type of research method where you're going to manipulate a couple of different variables and then measure their effect on one or more dependent variables. Experimental design means creating a set of procedures to test a hypothesis. So usually an experiment is like one thing that you're doing in the lab. And a lot of students will refer to their research project as an experiment, but your research project is the whole thing. An experiment is like a small component of it. So before you design your experiment or experiments, you should have a good understanding of what you're going to be looking at, what system you're using. Consider the variables that are going to be involved, and then make predictions that are specific and testable. So faculty are supposed to do this all the time with our course learning objectives. If you've seen those on the syllabus, we have to find a way that we can specify what a course learning objective is and then test it. So how are we going to measure that? Well, if I want to test your knowledge of reactions, I'm going to ask you X amount of reactions, and I think that 70% of the students will be able to answer these type of questions. So there's a lot of math involved there. It's something that we can measure. Otherwise, some of the course learning objectives for USEM are really stupid. It's like, we're going to measure grit. I don't know what the hell grit is outside of filtering things, and there's grit in your reaction mixture. So because the person that wrote the USEM outcomes is not a scientist, there's not a lot of things that you can measure accurately. It's subjective. So there's a lot of things that involve feelings in the USEM course learning objectives. Hopefully for your senior research projects, you have things that you can measure with the value or do statistical analysis on, other than the students felt, involved or whatever. Okay, so you can make predictions that are testable, and then are your tests valid? So are you running good tests to actually figure out if your hypothesis is valid or not? And you have things like randomized controls, controls period, independent controls, in things like injection standards. If you're using mass spec, you want to have something like an injection standard or an internal standard. Does anybody know what an internal standard is? A little bit? Kind of, sort of. So when I worked at the University of Minnesota, we did urine analysis, and we wanted to find out if, the part A, you have a negative control, so that's non-smoker urine, whose P we're always measuring, and then you have a positive control, which is somebody's smoker urine. So you have always those two controls whenever I did a batch of samples. And we would put in an internal standard, which would allow us to measure how much of the stuff was carried through. So every single sample got injected with a deuterated nicotine derivative so that we could measure it against the other things. So we're measuring phenanthine tetryl, and then we have a deuterated sample in every single sample. So you can see, then you can compare apples to apples with the negative versus the thing, because the negative sample is always going to have that deuterated one, and then the positive samples will have deuterated plus the regular one. So that's going to be some of the standards that you want to think about, or variables. Okay, so step 1 is to define your research questions and variables. So you start with a specific research question. So there's 2 examples here. One of them is, let's say you wanted to look at the number of minutes of phone use before sleep and how it affects the hours of sleep that you have. Or how does increased air temperature near the soil surface affect the amount of CO2 given off? So then you can define your main variables and make predictions. So this group is using the independent variable is the minutes of phone use before sleep, and the dependent is the hours of sleep per night. So let's say 60 minutes of phone use before sleep is going to have this amount of effect on your sleep. So maybe you get 1 hour less of sleep because you're using 60 minutes of phone time beforehand. And for the temperature and soil respirations, you have air temperature above the soil is what you're measuring, and then how much gas is given off is what the dependent variable is. So you also want to account for confounding variables. So this was a new term to me. I knew what it was, but I didn't know that was the definition of it. So a confounding variable is one that's unmeasured, but it influences the cause and effect. And it usually is correlated with the independent variable. It could be the cause, but it doesn't have to be. And it must be causally related to dependent. So the example here is you collect data on sunburns and ice cream consumption and find that higher ice cream is associated with higher probability of sunburn. So does that mean that ice cream consumption causes sunburn? Probably not. So this would be a confounding variable. So the confounding variable is temperature, because hot temperatures cause people to eat ice cream more often. And then you also spend more time outdoors under the sun, which results in sunburns. So you want to account for these variables. You might have a cause and effect relationship and you might not. So some of these things that always crack me up are things like people make this association, it's incorrectly correlated, right? So women that have breast cancer wear bras. So that means that wearing bras causes breast cancer, right? Or people that have cancer eat white bread, and eating white bread causes cancer. So I actually had like a 25-minute at least like argument with somebody in graduate school about how eating white bread does not cause cancer. So there are people, and that was one of the assignments I was going to have you do, is to go find something ridiculous like this and look on the internet and see how many pages will support a ridiculous theory, but you can do that on your own time if you want to. But it's amazing what kind of data you can find if you really want. Okay, so you have hot temperatures will cause the rate of ice cream consumption to go up, assuming you're not lactose intolerant, and then the number of sunburns will also be impacted by that. So to get around that, you can use something like restricting your treatment groups. So you start with subjects of the same value and then try to account for these confounding factors. So the example here is if you're studying low carb diets and you think it causes weight loss, and you know probably that age, sex, level of vacation, exercise intensity, all of these are factors that could be associated with weight loss. And then the diets you choose your subjects to follow, you choose to restrict your pool to just 45-year-old women with bachelor's degree who exercise at moderate levels of intensity, 100 to 150 minutes per week. So this is a way to kind of narrow your window down. Instead of doing a huge study, you can just pick a small thing. And this is going to be something that's measurable and you can compare it more closely. Because if you did something with men and women ages 15 to 60, the metabolism of a 15-year-old is going to be much different than it is for a 60-year-old. Like I could probably eat carbs when I was younger, but now like that does not happen. They love me so much, they never leave my body. So low carb diets for some people, if you can narrow your window down, you're going to have a more or a better study. So then you want to select a comparison that will match your treatment group. So you want to have the group that, you know, gets the low carb diet and then one that doesn't get any restrictions, or you can restrict other things about them. So this allows you to eliminate these other factors. So you can match up subjects on age, sex, level of exercise, and exercise and education, or you can widen the group if you wanted to. So you can include men in the treatment group of different ages. And this is why a lot of times if you're doing surveys, they ask you your age, race, all of these other questions before they actually get to the studies, so that once you have that data there, you can go back and resort things. And so like if they found a correlation between women that were 30 years old, that might have some certain effect, but then if they also tie in the level of education or, you know, social status, that could be another factor too. So you can, if you have these subjects, you can match them with similar characteristics, like I mentioned. For a 4-year-old with highly educated man can follow a low carb diet, and then you find another man, a highly educated man who doesn't, and you can compare the two. Statistical control, this is where you have all of the data. If you've done this like lengthy, is anybody planning on doing projects with people? Survey-wise? No? Okay. But if you did, you would get all of this background information so that you could have things like exercise level, if you needed their, parents' income level, if that was going to play a factor into things as well. So that might be something. Sometimes with students surveys here, they'll ask if you're first generation, because that could have an impact on how much students are staying in college and not. And that we find a lot of times first generation students tend to not make it all the way through the 4-year schools just because they don't have that support. So there's a lot of variables that can play into this. So if you can control those either with statistics or otherwise, that's going to be helpful for you as well. You can randomize things. So you've heard of placebo and control group. And then so you can have a group of these participants and you select randomly half of them to go on the low carb and then half to consume or continue normal eating. And then randomize your guarantees that both your treatment group as well as your control will not only have the same average exercise, age, and etc., but they'll have the same things that you haven't measured as well. All right, so if we go back to our phone example, the phone use and sleep. So the confounding variable is your natural variation in sleep patterns. So that's not something that you account for because I can't fall asleep at the same time every single day in the same amount of time. Like some days it takes longer, some days it takes less. If you have a lot going on, like you can't turn your brain off. So that's going to be a factor that you can't necessarily plan for. But to control it is to control it statistically. So you can measure the average difference between sleep with and without a phone. So if you were going to start the study, you have the person not look at their phone at all and then collect a couple of days of sleep patterns ahead of time or get a baseline, if you will, and then you could measure after. For the soil, you have soil moisture also affects respiration, and moisture can decrease with increasing temperature. So controlling it experimentally. So you might monitor the soil moisture. If it's dry on some days, you want to add water to it in order to equalize the experiment. So there's the different pictographics there you can see. So there was a student that maybe thought about doing, or no, it was a paper. I think somebody was looking at decaying bodies in the desert or something. And there's variables that you can have there that you might not think about. So if you wanted to put like 2 coyotes next to each other, and then you're doing duplicates. But one thing that if they're rotting and they're decomposing naturally, the things that you might not account for that you can't measure are animals that scavenge, like that might interfere with that study. So what you have to do to get around that is to put a cage over top of it. But you don't want to put like a protective box because then you're messing with the nature part of it. But if you have a cage, that can at least allow things to erode and do whatever else, but you can't have the animals go in there. All right, hypotheses. If you are doing a project that actually allows you to have a hypothesis, you can have a null hypothesis, which is kind of a, yes, this is true, no, this is not. So phone use before sleep does not correlate with the amount of sleep a person gets. And then, because after you measure this one, you can say definitively it does or it does not. And then there's the alternate, which is just increasing phone use before sleep leads to a decrease in sleep. This one's also kind of a yes, no, but there's more wiggle room in your hypotheses because it leads to a decrease in sleep, but how much? A little bit, a lot, like what's going to be significant for you. So those are things that you don't necessarily have to define right up front. And you can always change your hypothesis later on too, as you collect data. For the temperature of the soil, you have air temperature does not correlate with soil respiration. And then the other one is increased air temperature leads to increased soil respiration. So for that particular study, if you were measuring the amount of CO2 given off, you have to think about also like the equipment itself. Is that going to affect the study? Because I'm not sure how you collect CO2 coming off of soil. But if that is going to, have a cage over top of it, then you're also going to affect the scientific study there. All right, then you're going to set up a controlled experiment. So you can try to manipulate the different variables or measure the dependent variables and then try to control any potential confounding variables. So once you get your design kind of figured out, account for those variables and make sure that you have them in your experiment. So one of the things is like replicates. If you can run samples 3 times and make sure that you're doing things consistently. I talked about injection standards or injection replicates. So you could put 2 of the same sample next to each other in the mass spec line or, you know, first and last to make sure that the values that come out of it at the end of the day are the same thing or similar. If they're very different, then there's something wrong with the instrument. You want to go back and check that again. So if you're taking instrumental or you took it and you did things with calibration curves, you know that every time you run standards and you want to quantitate them, you have to do a new standard curve because your instrument's going to be different from day to day. Sometimes you might get the column that was like clean and then somebody might have gunked it up. So if your integration area on one day was, you know, 62,400 and then another day it was like 600,000, those are going to be very different. And you can't use the same standard curve for the different samples. So you always run those before your samples, or at least on the same day as the samples. Okay, so how wide or fine do you want to control the experiments? So if you're using the phone one, there's a categorical value. So you can do no phone use, low phone use, and high phone use. And you can define what those things are, those variables are, or you can just have people track the number of minutes used every single night. So that's another way to control the experiment. You have, you know, definitions of them, or just whatever you want it to be, but measure the values of it and just keep track of it. And then for temperature, you can choose to increase air temperature. So just slightly above the natural range for your study, over a wider range, or over an extreme range that is possible beyond natural variation. So I think one of the biology students did something with worms and like the mass of the worms, and she had different moisture levels where it was like soupy, but then she found that if the dirt was like overly soupy, like the worms died, suffocated. So that's another thing that you might not think about in your study as well is can stuff still grow in that condition if that's what you're measuring? Okay, and then assign your groups. More subjects equals greater statistical power and more confidence in your results. So if I polled you guys about like who likes to eat Cheetos and like everybody said yes, then I could say everybody loves Cheetos, but that's not true because this is a small sample size. So if you're doing things with strains of hemp or CBD, try to find more than one hemp strain. You know, multiple is going to be better. Especially if you have, so we had a student doing, trying to think of an example. She was looking at different congeners. Do you guys know what a congener is? So in like brandy or apple brandy, I think she was looking at, there in alcohol things, there's like the bottom shelf alcohol versus top shelf. The ones in the bottom haven't been distilled, so it has other things in there like ethyl acetate and isoamyl alcohol. So there's different derivatives that are in the samples themselves. And I think she only measured it in 5 things, but didn't compare things. Like if it was me, her advisor, I would have asked her to look at a couple of different bottom shelf, mid, you know, and all the way up to the top that have the high purity. And that's what I would have done because you have randomly assigned groups. There's replicates. It's not just based on one sample. One of the things she did that was kind of neat was that she had her dad brewed apple brandy. So she looked at his as well, just to do the comparison to see where that fell. But if you have a larger sample size, that's going to be better for your study. You have a control group, depending on what your study is, which means that there's no treatment and there's no intervention. There's control groups where they don't get any treatment, or you have placebo. And you're going to see that a lot, especially with human trials. I don't know if they're doing that with COVID. Are there placebo for that? There probably is placebo.
Probably some sort of.
But if you're not dealing with human samples or doing that kind of testing, but you would have a control for that where there's no treatment. If you do cell studies, the control group or the no treatment is usually what we call the vehicle. So if you were testing drugs or something, it's got to be dissolved in something. So if you dissolve it in DMSO and you add the DMSO with your drugs in it to a plate of cells, you would also inject the cells with just DMSO. And that makes sure that the DMSO is not having an effect. But then you could also have a sample with absolutely nothing in it to make sure that the vehicle also is not having an effect. All right, so you have different randomized versus completely randomized with the block. So then every subject is assigned to a treatment group at random. And then you have the ones that are grouped according to their shared characteristics. So for the phone, subjects are all randomly assigned a level of phone use using a random number generator. So if you had me for an instructor for Gen Chem Lab, that's how I assigned the partners. That was just a random number generator, just so that you don't have influence or anything. So you might, pick half of the room to this and do half that, or you can just have it spit out numbers. Subjects are then, after you've randomly assigned them, you can group them by age, and then phone use treatments, and then they can be randomly assigned within that as well. For the soil, they just had different soil plots at random by using a number generator again, and then they checked it by average rainfall and treatment plan. So if you're looking at soil respiration, you want different kinds of landscapes, different climates, if you can go to different areas. So some of these biology students will sample water at different parts of Michigan, not just all in the stew, so they can get a more representative sample size. Some of this randomization can be not practical and also not ethical, so you watch out for that as well. Again, maybe not so much in our class because you're not doing stuff with humans. You have independent measures, design, and repeated measures. So there's an independent ANOVA, and so the individual receives only one of the possible levels of treatment, or you have repeated. So for the phone use, you are assigning them a level of phone use as low, medium, or high, and then they follow that through the whole experiment. So you're not going to switch them halfway through. Or they can be assigned to consecutively to low, medium, and high throughout the experiment, and they follow the treatment. So maybe you have them go low for 3 weeks, medium for 3 weeks, and then high for another 3 weeks. And then for the soil plots, you can have randomized temperature. So instead of, if you wanted to remove the external, you can actually control the temperature for each of those soil plots if you're doing it in the greenhouse, and then try to have different temperatures above ambient temperature for that. All right, so remember that these are always context dependent. So some of your experiments, we're not gonna have this. Again, if you're just working on synthesis of something, your project, you're not gonna have a hypothesis of, I hypothesize that I will make this compound. You might be creating a library, and so your controls will be different there. And a good example will just take everything into account of the unique considerations. And you want to produce information that is valid and also relevant to your research question. So make sure it is related. All right, so we're gonna do an example here. So the question is, can cocaine be found on paper currency? So what kinds of things, and we can type them up here. What kinds of things do you need to consider if you're doing this experiment? So let's say this was your senior project. This is one of my seniors' projects right now. What kinds of things do you need to consider?
So for like your samples, you're gonna want to get like cash from different places.
Mm-hmm. So if you're at home, you can type in a query also for this to contribute. Okay, so cash from different locations. And even within locations, you have, you could think about places that are low cash flow. So like a small business versus high flow, like Walmart. I'm not this bad at typing, I swear. So low cash flow versus high. What else would you consider with this one?
Would he be like different bill sizes, like one?
Yep. Dollar increments. Go there. What else? could look at geographical location.
Would a good control be like a new bill that hasn't been in
Mhm.
circulation before?
Yep, new bills for control. What could so that would be a negative control where you're not going to find a trace. What could you use for a positive control? What could you use for a positive control?
Could you use like over-the-counter medicine and try to see if you can get that off it?
Yep. So use OTC medication. So this would be part of the things that you want to work on before you actually test, right? To see if you can swab off of it. So use OTC medication to test if what else? What else could you use for a positive control? So with my urine samples, we spiked it, right, with a deuterated version. If you could, and the university allowed us to have possession of cocaine, we could spike the dollar bill with cocaine and put it on there, you know, shake it off and then see if we could swab on there. So spike with actual cocaine. Some of the things that we ran into, unless anybody's still thinking about stuff, you can still be thinking, is if we found dollar or, you know, stuff with cocaine on there, does anybody know, like if you were trying to see how much cocaine we need to put on there, like am I throwing grams amounts on there? So like how much is in a sample size of what people snort? Like this is not things you would think of normally, right? But if you're doing a positive control, you want it to reflect what the dollar bill is actually going through. So if a person is snorting cocaine and that much mass is going through, like what is that? Like how long is the line of cocaine? So things that you want to consider also is how much is snorted. How do you, cocaine is spelled wrong. Anything else you guys can think of?
The purity of the cocaine.
Yep. And what instrument or methods will we use to test either the amount of cocaine or the purity? We use NMR, IR, mass spec. Mass spec is good. And these are other things that you want to think about also. So my student wants to use mass spec. So you want to find a method. You have to be able to you search literature to find a method, because you can't just go into the lab and say, let's shoot it in the machine. You have to tell it what to do, right? So mass spec need method for LC. This one is not going to be a good one to use with, what is that one that you guys are using? Headspace, because cocaine is not very volatile. So you want to use it in the liquid phase, maybe gas phase, but probably liquid. And with one of the things that we're working on right now is use HPLC first. So you can use the HPLC, which is the cheaper, that doesn't have the mass part. But if you have a pure cocaine sample, and that's something that you can buy, is like these standards where they have a tiny bit in there so you can just check to see if it's pure. You know what the retention time is. And once you figure that out, a good method to run your sample, then you can take it and translate it into the mass spec. So you're using the cheap stuff first to figure it out and then go to the expensive things. Anything else you can think of that you would have to consider for a study like this one? I think not so much. Trying to think what else we had run into. So we're right now at the OTC phase to see if we can actually get the HPLC method working before we go to the dollars. But if you wanted to look at compounds similar to cocaine or other things, we mentioned THC, CBD, CBN, to see if you could swab off of that. Some of the methods for What was it? Oh, the getting cocaine off the bill. Some of it was just like putting the whole thing in like a tub of methanol, which then your dollar bill is like not really usable after that. So you want to find ways that aren't so invasive. Other things that you want to think about is, can you just dry swab it, and if it is anything going to stick to there? So that's one where we were going to use the OTC medication. So we're looking at Sudafed, acetaminophen, and aspirin. So if you sprinkle some on there, can I just take a Q-tip and then stick it in the methanol after that? Does the methanol, does it have to be dipped in methanol first? Is methanol actually a good one? Can I use ethanol or isopropanol? Will those things be better? So that's a lot of variables that you might not have thought about initially, but you want to think about that in your experimental design. And if you get to that level of detail on your junior proposal, your senior research, when you are able to do it, will be that much more meaningful. All right, does anybody have questions there, or questions about your project you want to brainstorm with the group? Not so much. Okay, that's all I have, unless you want to talk about cocaine some more. Yeah, I think that's cocaine. It would be interesting if we got, so initially we wanted to look at the Grand Rapids area and then compare it to the Sioux, but there was a lot of, with the COVID for everything. We didn't get to do that, so we're still working on this project right now. So. All right, so if you guys have nothing, I will see you all next week for presentation, the making of.
Compared to the schedule, like, I know we had a lot of
Hungry,
schedule
my
changes.
stomach's like,
I'm like,
Yeah, yeah.
I'm hungry, or
Okay,
they're
I
rather
don't think
just
so.
like
We finished that
sleep.
the week before break.
Yeah, I'm finishing mine today.
no, I'm
Where you are,
hospital shadow.
You what?
And then we
I'm in the
worked
hospital shadow.